Hello everyone and welcome back. I'm currently in the Introduction to Autodesk Inventor Solid Modeling module, and underneath the images that we've been using to create our 3D models and drawing files from, there's a note that's been here all along called TDJ3M Basic Dimensioning Rules for Orthographic Drawings. I don't know if anyone's clicked into it yet or not, but I'm going to be taking a look at it today and discussing the contents of the note. And this is a bit difficult to see through the hub for my video, so I'm actually going to go ahead and download this. It's in a PDF form, and open this up. So with the drawing file lessons that I've taught previously for the die punch and the right angle brace, I've been referring to a lot of information contained within this note, but I've never actually referenced the note. There's just been a lot of verbal dialogue in my lessons, a lot of explanation about dimensioning, but this is the note that I've prepared that shows you correct methods and incorrect methods. So we're going to begin and take a look. I use this for all my classes, even grade 9 right up to grade 12. So basic dimensioning rules for orthographic drawings. This is a reference to assist you in becoming a pro at detailing, which means dimensioning mechanical drawings. So number 1, very, very simple to understand. It says place dimensions off outside the views. So here's an example of correct and incorrect. This is actually the control bracket, and it shows all of the dimensions sitting outside of the drawing view. And in the incorrect box, it shows you here that they're sitting all inside of it. So this should be very clear to understand. Dimensions all have to be sitting outside of the drawing view at all times, never on the actual part view itself. And it looks a lot cleaner as you see here on the left hand side. So that's all I can really say about that. Very simple to understand. Number 2 states, do not place dimensions between the views when possible. And in brackets it says you can place a dimension between views if the feature you are detailing is more easily understood to the person who will be manufacturing the part. Hint: dimension features that only show a defined profile rather than a flat 2D perspective. So we're looking at the control bracket again. In the correct method, we are seeing some dimensions between two views. Now, this is a gray area of dimensioning. If there's an advantage to putting dimensions between views, take advantage of it. If not, don't do it. So when we look at the incorrect example, a lot of things are the same here. The only thing that's different is that these two dimensions, the 5/8 and the 1/4 inch, are placed on the right side view here. And actually either one is correct, but this one is more preferred. And the reason is it's easier for the person in the shop to understand dimensioning like this, where they can actually see a clear profile of the difference in shape. When you look at it on the right side view, again, this is just a flat 2D perspective of that view. It's okay, but it's easier to understand here. So that's why this is correct. That's why we're placing these dimensions between views. We don't want to put dimensions between views, but if there's an advantage to it, it's okay. And there's another example below here for number 2. And I think this will help to clear it up if you're still confused. So it says placing dimensions between views with no necessary reason also creates crowding. So look at the correct example, look at the incorrect example. A lot of things are the same in each, but what's the difference? The 1.750 and the 1.5 are placed between views, crowding this 3/4 inch dimension. And what's the advantage of doing this? When I can easily take these two dimensions and place them on the opposite side of the top view where they will not crowd between views with the 3/4 inches. Because the way it's dimensioned is exactly the same on the top view. Whether the dimensions are below or above, it's still the same dimensioning style on the same view, but we're just going to keep them outside the views to keep this clean. And one might ask, well, why do you place the 3/4 inch dimension on the front view? Why not place it on the top view out of the way? Well, that goes back to the same thing I was stating above. That here, this dimension is easier to understand because it's placed on a profile. Right? It's again, flat 2D perspective on the top view. So again, better understood here. Number 3, dimension each feature only once and only dimension the object lines or center lines associated with object features. Do not dimension the hidden detail lines or center lines that are associated with hidden features. So to clarify this, we're looking at the correct box here first. Everything looks as it should. What's the difference between them? Well, these dimensions here, the 5/8 and the 1/4 inch, we know that this is in the correct position, but it's also listed here on the right side view. All right, so this is considered over dimensioning. We're not going to be duplicating the same dimension through the other views within the drawing. We only want to place that dimension on one of the views one time in the best possible position. We want as little information as possible on the drawing to be able to accurately manufacture the part. So that's over dimensioning. Also, dimensioning to hidden lines is incorrect, meaning that if you were to identify this 3/4 inch and 1.75, you're also going to notice that it is duplicated on the left side here as well. Again, this is incorrect because this whole feature is hidden from your view. Some people may argue, well, we're dimensioning to the center line, but any center line that's associated with a hidden feature is also off limits. So this here is totally incorrect. The way you see this on the right side view is correct. Number 4 doesn't apply to us because we're not using AutoCAD in this course. So we're going to be skipping over number 4. We're going to be going into number 5. Autodesk Inventor users run dimensions and use the automatic gap indicator to know when to click to add a dimension to make sure they are not placed too close or too far away. So you can see, I don't know if you can see this, there's a little example of that here. Creating this 5/8 dimension and pulling it off the part, and then when it breaks, as I like to call it, or becomes dotted, that gives you an indication of where you should be dropping it, right? So Inventor gives you a hand with that type of thing to make sure you're not snapping dimensions too close and too far. Everything should be fairly consistent. I'm going to say consistency is the biggest thing. You can't have a bunch of dimensions super close in one part of the drawing and a bunch super far away. You really need to keep things consistent. So again, it says reference the 5/8 dimension. After the vertical line is selected, to add this to the drawing, as you pull the mouse from the vertical edge, the dimension extension lines and arrow leaders will turn dotted. This is where you should click to add the first dimension. Of course, you may have to play around with this a little bit. It may not be perfect at the start, but you need to come up with a spacing that is consistent. So I say that word over and over again because I'm really trying to make a point about that. Again, 6 dimensions must be consistently spaced from one stack to the next. And look at this example here. Right? We've got this dimension way too far away. This one here should not be further out from the 2 3/4. The dimensions need to be stacked smallest to largest, as it states here. Dimensions must be placed from smallest to largest. Inconsistent spacing when adding dimensions results in a drawing that does not look professional. See examples above. The 5/8 is pulled way out over to here. The 1 3/8 is way too close. These two dimensions are way too close. And so on. Look at the correct example. Right? There's a fair amount of consistency here. And you'd be surprised how many times I get drawings handed in that may not be this bad, but again, there's no care being taken in placing the dimensions. Number 7 says always include overall dimensions on one of the views in your drawing. So for an example here, we need to know how long the control bracket is, so we're stating it here as 4.25. This dimension is not listed on the image in the module that you work from when you create these models and drawings, but we add an overall dimension in. It's customary to know the overall thickness, width, and length of the items that you're dimensioning in the shop, because the person who's in the shop who's going to be building the part, they don't want to have to start adding numbers up. They're going to want to look at a drawing and actually see what the total height is, the total length, the total width, that sort of thing. And we can see that here, right? We've got the 2 inches. I know this dimension is included with the image on the module, but this dimension is not the 2.5, and the 4.25 is not there either, but we're going to be adding them in. And that this dimensioning lesson will be coming up in a day or so. But this is listed as correct as you see it. Everything looks good. Reference the 2.50 and 4.25 dimensions, which I've stated already. Number 8, always make sure arrowhead leaders in a chain of dimensions line up with one another. So we're looking at the correct box first. Reference the 9/16 and the 1 1/8 dimensions from each example. You're going to notice that these arrow leaders chain up perfectly. What do you notice? The only thing that's different on incorrect is that they don't. And this is unprofessional not to chain up the arrowhead leaders on a dimension. So remember, always line them up. An inventor will allow you to line them up fairly, I'm going to say not fairly, but very, very easily. Always make sure arrow leaders in a chain of dimensions line up with one another. Number 9. Here's an interesting one. Omit one dimension in a chain of dimensions. And I've mentioned this, of course, in my previous instructional videos on drawing file creation. I know I mentioned it in the right angle brace video. We have our overall dimension on each of the correct and the incorrect slides here. And in the correct, we're missing a dimension, and in the incorrect, we have it. So this is over dimensioning, right? Why do I need to know the overall if I have all 3 of these listed? And So it's basically the same information. It's just a bit overkill. We need to leave one of these smaller dimensions out. It's more preferable to have the overall dimension listed as stated above in part 7, because if we just have the chained dimensions together, that forces the person in the shop to have to get a calculator out and start adding these dimensions together, which is not a good use of that person's time. It's easier for them just to see the overall dimension and be able to cut the proper stock they need to actually build the part. Again, so we just leave one dimension out. So the example above on the right is an example of over-dimensioning. It is preferable to keep the overall dimension and delete a detail from the chain rather than display the opposite. And here's a very excellent and important feature. Dimension features that are obviously identical only once and include a suffix tip on the end. So the example above on the right is an example of over-dimensioning. The drawing will become too cluttered with the same dimension repeated over again. Tip stands for typical. Let's look at the correct and the incorrect picture. It's obvious that this radius is the same on each side. We're going to list it once, not crowding the linear dimension extension line. We're keeping it on the left side, and it has a tip on the end, so we don't have to dimension it twice. In the incorrect picture, we're seeing this listed twice without the tip. And again, why clutter the drawing? It forces us to have this dimension leader cross over this extension line. It's not required. This is how you should be running the dimension. Run it once, add a tip, and then everyone will know in the shop that it is the same feature. Let's see one more example below. Looking at the example on the left, by adding a 9/16 tip makes it very clear for the person who is manufacturing the part that the dimension is identical to the space above. Adding a tip on the end of the 7/16 hole allows for less detailing. In the end, we are trying to clearly detail the part by showing the least amount of information, dimensions, possible. So you can see that here. These holes are actually the same diameter. The ones that are passing through the top flange, as you see in hidden, and the ones you can clearly see on the bottom flange in a top view perspective. Incorrect, we're mentioning that it's 7/16 diameter tip. So now I don't have to go and add this dimension twice and then drop the tip, right? Like, it's much easier and less work just to do what I'm showing here. And that is the end of this note. So this takes a little bit of practice, and it involves some critical thinking. But that's what we're supposed to be doing these days. We're supposed to be critically thinking and problem solving. So if you really put your mind to it, and while you're doing your work, you examine this note, you should be able to detail your drawings very, very well, with maybe very few mistakes. And it's okay to make some mistakes, because I understand that you're in a learning mode here, and I don't expect you to be, perfect on your first go. So I expect that it would be normal to see a little bit of mistakes, but not tons of mistakes that would indicate that a note like this is blatantly being ignored. So that's one of my biggest peeves, you could say, about marking mechanical detail drawings, is the students that are just, going at it with their eyes closed and not putting any effort into making these things look correct, because the way we see the dimensions on the iPad image from this module, a lot of those, not all of them, but some of them are shown incorrectly, because it's trying to promote critical thinking. They come from a drafting book. So, those who take it seriously are going to have the best mark and the best results. So I think that's where I'm going to end this video. And then after this video ends, I am ready to have a discussion about it and take any questions or provide any clarification from this note. So I'm going to sign off now, and I will talk to you soon.